Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? Today this is the 10th lecture of chemistry grade first year. The chapter name is thermochemistry and the topic name is Hess's law and Born-Haber cycle. First is, what is Hess's law? The Hess's law, which states that the amount of heat evolved or absorbed in a chemical reaction is the same whether the reaction takes place in a single or several steps. Means the amount which will evolve or the amount which will absorb heat will be same. It doesn't depend on the path of the reaction, that from which path we are proceeding the reaction. It doesn't matter that whether the reaction takes place in a single step or several steps or paths. This means that the net heat of reaction depends only on the initial and final states and not on the intermediate steps. So, Hess's law, in certain cases, the enthalpy of formation cannot be determined directly due to the following reasons. Some compounds cannot be directly synthesized from their elements. The rate of some reactions are very slow to be subjected for enthalpy measurement. In some cases, side reactions takes place and produce products other than the desired one. कुछ केमिकल रिएक्शंस में एंथैल्पी ऑफ फॉर्मेशन को डायरेक्टली डिटर्मिन नहीं किया जा सकता. उसकी वजह ये होती है कि हमारे पास रेट ऑफ रिएक्शन इतना स्लो होता है कि हम फाइंड नहीं कर सकते, एंथैल्पी मेजरमेंट डायरेक्ट नहीं कर सकते. रेट ऑफ रिएक्शन स्लो होता. कुछ कंपाउंड्स ऐसे होते हैं फॉर्मेशन में, यानी जिसकी फॉर्मेशन हम कर रहे होते हैं, कुछ कंपाउंड्स ऐसे होते हैं कि जिनको डायरेक्टली सिंथेसाइज नहीं किया जा सकता उनके एलिमेंट्स से. उनको पहले इंटरमीडिएट बनाना पड़ता है और फिर उनको सिंथेसाइज करना पड़ता है. तो कुछ कंपाउंड्स को डायरेक्टली सिंथेसाइज नहीं किया जा सकता, इसलिए उनकी स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन को डायरेक्टली डिटर्मिन नहीं किया जा सकता. सेकेंड बात ये आ गई कि उनका रेट ऑफ रिएक्शन स्लो होता है. तीसरी बात यह है कि हमें हमारा जो डिज़ायर्ड प्रोडक्ट होता है या जो हम लोग डिज़ायर्ड कंपाउंड बना रहे होते हैं उसके अलावा एक साइड प्रोडक्ट बन जाता है, यानी जो कि हमें ज़रूरत नहीं होता. इस वजह से डायरेक्ट मेजरमेंट एंथैल्पी ऑफ फॉर्मेशन की पॉसिबल नहीं होती. तो एक साइड प्रोडक्ट अदर देन द डिज़ायर्ड प्रोडक्ट, मतलब जो हमें प्रोडक्ट चाहिए वो नहीं बनता और एक साइड प्रोडक्ट बन जाता है, यानी जो कि हमें नहीं चाहिए होता. तो ये तीन केसेस हैं कि जिस वजह से हम स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन को डायरेक्टली डिटर्मिन नहीं कर सकते. सो सम कंपाउंड्स कैन नॉट बी डायरेक्टली सिंथेसाइज्ड फ्रॉम देयर एलिमेंट्स. द रेट ऑफ सम रिएक्शंस आर वेरी स्लो, and in some cases the side reactions takes place and produce products other than the desired ones. So if two or more chemical equations can be added together to produce an overall equation, the sum of the enthalpy equals to the enthalpy change of the overall equations. We will add the enthalpy change of both the reactions, and this is also called as heat of summation, and it is denoted by del H. So Hess's law states that the total enthalpy of the reaction is independent of the reaction pathway. It only depends on the initial and the final states, and it only depends on the amount of heat evolved or absorbed. Doesn't matter that which steps and how many steps we are following. So important of Hess's law allow us to calculate the enthalpy changes of reactions that cannot be measured directly in the laboratory. I have told you that when we cannot measure the standard enthalpy of formation directly, this may be occur due to the following reasons: that a side product may be occur, rate of reaction may be slow, or the compound cannot be directly synthesized from their elements. Means that there will be some intermediates will be formed that prevent the formation of our desired component. Enthalpy diagram for Hess's law. This is A plus B is the reactant and C plus D is the product. At first step, A plus B is the reactant, is converting into an intermediate product by the change in some enthalpy, that is del H1, and then intermediate product is then converting into main product, our desired product, that is through del H2, change in enthalpy, and the final product is C plus D. So according to Hess's law, the total absorption of heat is the sum of heats involved in different steps. Sum of heats. When we say heat of summation, it means sum of heat. That is, Q is equal to Q1 plus Q2 plus Q3. Q is for heat, and this is the sum of heat evolved or absorbed. Heat of formation. Carbon monoxide, for example, is prepared by reacting carbon with oxygen. As you know that carbon reacts with oxygen to form carbon monoxide or carbon dioxide. So carbon monoxide along with carbon dioxide is formed by reaction of carbon with oxygen. So to determine the heat of reaction for carbon monoxide formation, an indirect method is used. Which indirect method is used for the production of carbon monoxide? In the first step, the carbon will react with the half mole of oxygen to form carbon monoxide. This is 3/4 part, means the high hissa. Second is carbon react with oxygen, 1 mole of oxygen to form carbon dioxide. Third is this carbon monoxide then react with half mole of oxygen to form carbon dioxide. And in the final step, carbon react with half mole of oxygen to form carbon monoxide. The reaction is highly exothermic. The heat is released. The second topic is Born-Haber cycle. The Born-Haber cycle is based on the principle that the sum of energy changes which occur in a closed cycle from the same initial and final states is zero. Sum of energy changes that occur from initial to final state is zero. This means that this involves the law of conservation of energy in accordance with the first law of thermodynamics, that energy can neither be created nor be destroyed, but remains conserved. So the sum of energy changes which occur in a closed cycle from initial to the final states is zero. It means that there is no change in energy and the energy will be conserved. We can represent it with law of conservation of energy. Here are some basic definitions. We have already studied these topics, that is, standard enthalpy of sublimation is the heat absorbed when 1 mole of atoms are vaporized. Sublimation is a process in which solid get converted into gas directly. So it means that when conversion into gas occur, so it means that vaporization will be occur. Standard enthalpy of bond dissociation means bond breakage. It belongs with the strength of bond. The third is electron affinity. The electron affinity is the energy absorbed when 1 mole of ions are formed from 1 mole of atoms. That is, from atoms, ions are formed. The energy which is absorbed when from atoms, ions are formed. The standard lattice energy is the energy absorbed when 1 mole of ionic crystals is formed. What is standard lattice energy? When 1 mole of ionic crystals is formed, the energy utilized in the formation of 1 mole of ionic crystals. And standard enthalpy of atomization is the energy absorbed when 1 mole of atoms are formed. That energy which is used in the formation of atoms. And what is standard heat of formation? The standard heat of formation is the amount of heat given out when 1 mole of a compound is formed, when 1 mole of ionic compound is formed from its element. For example, sodium chloride. This is actually the standard enthalpy of formation. Here NaCl will be formed at that of the reaction.